If we graph the situation where we start at clock time t and double to some time t plus t sub d, where t sub d is the time it takes to double starting at clock time t, we see that we have principal p of t at clock time t and p of t plus td at clock time t plus td. If t sub d is a doubling time, then p of t plus dt here is double the p of t that we have here, and we have this equation, p of t plus dt equals 2 times p of t. Using the principal function that we have, 10,000 times 1.07 to the t, this equation could be written as 10,000 times 1.07 to the t plus td equals 2 times 10,000 times 1.07 to the t. This is an equation that we can solve for t sub d. The question here is, does t sub d depend on what t is? Does it make any difference when we start our doubling? Okay, if we start our doubling at clock time t equals 0, or t equals 5 years down the road, or t equals 3.5, 3 years down the road, does the doubling time depend on when we start measuring the doubling? Let's look at this equation that we've just written again. The equation is 10,000 times 1.07 times the t plus td equals double 10,000 times 1.07 to the t. That is, again, the principal of clock time t plus td is double the principal of clock time t. If we divide both sides by 10,000, we end up with 1.07 to the t plus td equals 1.07 to the t doubled. Now, the laws of exponents tell us that 1.07 to the t plus td is the same as 1.07 to the t multiplied by 1.07 to the td. That's a little fact of exponents that you might not be quite as comfortable with as some of the others, but you will certainly remember that a to the b plus c is the same as a to the b times a to the c. So that we can replace this left side with this expression. What does this do? Well, this allows us to divide both sides by 1.07 to the t. On this side, we're simply left with 1.07 to the td, and on this side, the 1.07 to the t divides out, and we're left with 2. This is the same equation that we saw before. 1.07 to the td equals 2. Its solution is td equals log 2 over log 1.07. And this proves that the doubling time t sub d does not depend on the clock time when we start measuring.